right, so let's start with our bell work here. So this problem basically takes the last journal entries table, and in this case it says, well, if Miss Chang sells those lemon pies for $1 a slice and the apple pie for $2 a slice and the Hershey chocolate pie for $3 a slice, how much money did she make total for each day? So you can see in this table, I have the number of pies I sold for each type for Monday, Tuesday, and Wednesday. So basically what it's asking is it wants to know the profits made for Monday, Tuesday, and Wednesday, given all the pie types. So how about pause for the video and see if you can figure this out. Now, you don't need matrices to do it, so see if you can figure out a way to add up or total up all the profit for Monday, Tuesday, and Wednesday using the prices given. All right, so now I'm going to show you how to set up this problem using matrices. So we learned last time that matrices, or matrix as singular noun, is basically this box or this rectangular array that holds stuff, and usually numbers, right? Or quantities in this case. So basically what I'm going to do is just copy and paste that there. And this will be my matrix for the quantity that I have. So I have a quantity of pies for a given day. So Monday, Tuesday, Wednesday. And so this is 7, 5, 4, 5, 8, 3, 6, 4, 7. And then what I'm going to do to think about this logically is like I want the profits for Monday, Tuesday, and Wednesday. You know what? Let's write this as a matrix that I'm going to get. So I need to get the profits for Monday, Tuesday, and Wednesday. So maybe I'll figure out what Monday is and put it here, Tuesday, and then Wednesday. So this matrix will be the profit that I'll put my answer in. So when I'm thinking about this problem, and I just want to focus on getting the amount that I made on Monday, well, that means I'm going to have to multiply like $1 to the 7 lemon pies I made, $2 to the apple pies that I sold, and $3 to the Hershey chocolates I sold. So because I'm about to multiply the prices to the corresponding pie quantity, I might as well just build the matrix for that, right? I can just put, this could be representing prices, so I'll just call it dollars. So this will be 1, 2, 3. How about I do this? I'll put, this is for lemon, apple, and Hershey chocolate, and this is for about prices. So what I'm going to do here is basically multiply this $1 with 7, $2 with 5 apple pies, and $3 with 6 Hershey chocolate pies. So basically I'm multiplying this row with this column. So in this case, $1 times 7 lemon pie is $7 plus, because I need to add the next one, $2 times 5 apple pies is $10. 3 times 6 Hershey chocolate pies is 20, oh sorry, not 20, 18. And if I total this up, it looks like this is $35. So I know for Monday I made $35. Well, what I just did there was I multiplied this matrix to get this profit that I'm going to find. So I'm going to find, basically when I find my profit, I'll just put it as a matrix. All right, so now I'm going to multiply this row, the prices, to this column, Tuesday, to figure out Tuesday's profit. So again, it's very similar as I was doing it for the other ones, or the last column. So I'm going to multiply my $1 with 5 lemon pies, which is $5, plus $2 times 8 apple pie is $16. $3 times 4 Hershey chocolates is 12. Yeah. And then when I add this all up, let's see here. So 5 plus 16 is 21 plus 12, that's $33 for Tuesday. And then last but not least, I'm going to be multiplying again the price with the third column, which is Wednesday. So in same way as I did before, 1 times 4 is going to be $4. $2 times 3 apple pies is going to give me $6, plus 3 times 7 is $21. So if I add them all up, it is $31. So on Wednesday, I made $31. And you can see here, I've basically figured out my profits in a matrices multiplication. So the reason why I want us to look at how to multiply matrices in this fashion is because I want you to see how a computer would think, okay? So computers are very good at calculating data as long as it's organized like this, and specifically in a matrix. So like when you walk into, like my shop is very small. Like I'm only selling 3 items for 3 days out of the week. Now Walmart is like 24/7 open store with thousands of product, right? So Walmart has to do a better job of keeping track of everything. And well, they have to keep track of their prices, which is this large matrices as well that keeps track of all the prices. But in addition to that, they also have a matrices that keeps track of like the items that are being scanned throughout the day. And so when you multiply the quantity with its corresponding price, you get the total amount you made that day. And Walmart can easily keep track of that with its computers because the computer, some human coded it to be able to do that, but it's all this type of math. And that's the beauty behind it. So what we're going to do is look at a smaller scale of it so that we can understand the foundation of it. So today's theme is learning how to multiply matrices. How does that work specifically? All right. So in this one here, the slide goes over definitions on the rules for multiplying matrices. So just read along with me, basically. You can only multiply matrices if their inner numbers match. So using this as our example here, A and B are both matrices. So just imagine if they were these boxes with, numbers inside. And what I've already done is figure out the size for this matrix and figure out the size for this matrix. So the first thing you have to do is figure out the size. Once you do, basically what you're going to do is take a look at their inner numbers. So basically the column in the first matrix and the row in the second matrix. And you're going to compare. And I call these two numbers inside basically the inner size or the inner dimensions. And what they have to do is match. If they match, that means that you can multiply the matrices if the inner numbers match. If they don't match, kudos for you, you can just call it undefined. So you can't multiply them if the inner dimensions do not match. So now we're going to look at the outer dimensions. So let me grab the outer dimensions here, which would be my M and my P. And basically, so if the inners match, basically your outer dimensions act as your resulting size for your new matrices after you've multiplied. So we refer to these outer numbers, just the outer, and then they are your resulting size. And I'll explain what that means using the example. So basically when you multiply them, you got to make sure the inners match. And if they do, that means the new matrix is going to be the same size as the outer put together. All right, so in the next slide here, we are going to do 2 examples where you kind of get to see a variety of this. But I also want to mention when you multiply matrices, we're always going to use the rows from the first matrix, and the second matrix, we're always going to use the column. So we always multiply rows by column, and like I said, we're going to see it in the next example here. All right, so here we're going to multiply these 2 matrices. The first thing you want to do before you start multiplying is to figure out the sizing. So in this case here, you can see there is 1 row, and it looks like 2 columns. Right, so you have 1 row and 2 columns, and this next one next to it kind of looks like a square to me, so I know it's the same size. So 2 rows and 2 columns. And so what I need to do to make sure I can multiply is look at the inner dimensions, right? So this is what is referred to as the inner. And check it out. They are the same number. They match. So because they match, that means that I can actually multiply. So when I multiply, my new matrix is going to be the outer dimension. So I am going to get a 1 by 2. A 1 by 2 is basically one row and 2 columns. So what I'm going to do is in this matrix, I'll work it out, and then later I'll try to clean it up. So I'm going to try to show as much work as possible. Maybe I have a feeling that I might need more space. So I'm just going to make this a little bit bigger. All right, so what we're going to try to do here is we're always going to use the rows from the first matrix. So your first matrix, you're only going to use its rows. In the second matrix, you're always going to use the columns. So starting with the first matrix, you're always going to take the rows. So I'm going to take the first row and the only row and multiply to the columns in the second matrix. And when you do this, you're going to multiply the first number in this row with the first number in this column. And then you're going to add it with the second number multiplied by the second number in the column. And you keep doing this until you run out of numbers in that row or column. So in this case, I'm going to multiply the first numbers together. 9 times 2 gives me negative 18 plus, so you always add after, negative 2 times 6 gives me negative 12. And so what I'm going to do here is always add the numbers after you multiply the corresponding ones. So when you add them, you get, well, negative 18 plus 12 is, let me write that out here, is negative 30. Yep, that's it. And now I'm done with this column. Notice how I still have one more column here, and notice how I'm like missing a spot here, and this is the second column. So in this case, I'm going to take now, again, the same row, but now multiply it to the second column. So in this scenario here, 9 times 4, so you always multiply the first numbers together. So 9 times 4 gives you 36 plus, always add, the second number times the second number. So negative 2 times negative 7 gives you 14. And then when you add them, you get 50. And so in this case here, you get a matrix with 2 elements inside because this is a 1 by 2. We learned last time when you multiply the sides together, 1 times 2 gives you 2 elements. Well, surely enough, there are 2 elements in here. And that's it. You have your new matrix after you've multiplied. It's kind of thick. Let me change that. Or maybe I just won't circle it at all. There we go. All right, so now in the next one here, remember we want to start off by figuring out the size of your matrix. So this one here has 2 rows, 3 columns. So this is a 2 by 3. This next one here looks like another 2 by 2. And so you can see this time around, if you look at the inner dimensions, they don't match. This one's a 3 and this one's a 2. So since they don't match, that means that, well, this is undefined. Because you can't multiply if they don't match. You're not going to have enough numbers to multiply its rows and columns together. You're going to be missing a few spaces. So that means we just can't multiply. All right. So the next thing here is I'm going to do some more problems from your homework. So now if you want to turn to your packet, I'm going to do 2 problems from your packet. All right, so let's start off with this one here. So again, we want to start naming the size of the matrix first. So again, we have a 2 by 3 again. So 2 by 3. This one looks like we have 3 rows, right? 3 rows, but just 1 column. Notice how skinny it is because it has 1 line of column or vertical line of numbers. So in this case, notice how the inners do match. So because they match, we do get to multiply them. But you can see that the outer dimension is a 2 by 1. So this is actually a very skinny or very small matrix. So it has 2 rows and 1 column. So I'm just going to make about this size. Don't know how big I need it. I'm going to try to show all my work in here, just like how I did it in the journal. So in this case here, remember, we always start off with rows, grabbing rows from the first matrix and columns from the second matrix. So I'm going to start off by grabbing the first row and multiplying by the column, right? So in this case, I have to multiply the first number with the first number, second number with the second number, third number with the third number, and then I'll add them up. So -7 times 3 gives me -21. Add that to 1 times 4 is 4, plus 0 times 0 is 0. And so if I were to add these number up, let's just write a new matrix here. -21 plus 4 plus 0 is -17, I think. Yeah. So then the next one here, notice how this row is done because I have no more columns here to multiply. So I'm going to now move on to the second column and now move, second row. So this is the second row multiplied by the column again. So in this case, remember, we're going to multiply the numbers, the first number with the first number, second with second, third with third. So 8 times 3, 24. Plus -6 times 4, -24. Plus -2 times 0, 0. And so when I add all these numbers up, 24 plus -24 gives me 0. Add another 0. Well, that's just 0. So now you can see that I've cleaned up my matrix and simplified it to here. So this is really just -17 and 0 inside. And there should only be 2 elements inside because 2 times 1 is 2, so 2 elements inside. And I am done. So this is my final answer. All right, so in the next one that I'm going to do here, how about I do number 3 with you guys so that way you can see how that one's done. So here's number 3. I'm going to zoom it out just a little bit. There we go. So again, we're going to have to figure out the size. So we have a 2 by 2, a 2 by 3, it looks like with this one. And so immediately I notice that the inners do match. So that means that my outer, that means that I can multiply these two and my outer dimensions are 2 and 3. So that means I'm going to be producing let me make this a really big matrix so I can fit everything, a 2 by 3. So that means I'm going to have 2 rows and 3 columns. So in this scenario here, I'm going to try to work this out. So let me grab my highlighter here. So like I said, you're always going to start with the rows first in the first matrix and then multiply it by columns in the second. So 4 times 1 is 4, plus 2 times 0 is 0. So that means if I were to add these two numbers, I'm going to get 4. So here's what I'll do. I'll make a new matrix, same size. It's still a 2 by 3, but now I'm going to clean this up and call it 4. And then my next one, notice how like in this row, I've only multiplied to this column, but notice how there's more columns here, so I need to move on to the next column. So now I'm going to multiply this row with the second column. So 4 times 2 is 8 plus 2 times 2, which is 4. So that gives me 16. Sorry, not 16. What am I thinking? 12. 8 plus 4 gives me 12. So my middle number here is 12. And then notice how I still have one more row here. So I'm going to multiply, or one more column here. So I'm going to multiply this row with this column. 4 times 3 gives me 12 plus 2 times -1 gives me -2. If I add together, this gives me a 10. And so my last digit's a 10. Notice how like I have an empty row here. So this is the first row, but I don't have the second row. It's because I haven't used the second row here. So Again, I need to start by going to now the second row. So let's see if I can erase this. I can't erase, well, oh well, that's okay. I'll just use different colors. So now I'm going to take the second row and multiply it to starting with the first column. So this row times this column, so 1 times 1 is 1, plus 3 times 0 is 0. And so if I add, that's just going to give me a 1 here. So now I'm going to multiply this row with this column. Let me use a different highlighter here. So in that case, 1 times 2 is 2, plus 3 times 2 gives me 6. So if I add these two numbers together, I get 8 right here. And then last but not least, I'm going to multiply my row with this column here. And I'll just do, I don't know, red. Oops. To do red. So 1 times 3 is 3, plus 3 times -1 is -3. And so that's going to give me 0 when I add them. And now I have my new matrix. And notice how 2 times 3 gives you 6 elements, and I do have all 6 elements inside the matrix. And there we have it. So remember, this matrix, the first matrix, you'll always use the rows until you run out. This matrix, you always use the columns until you run out. And that's it. Hope this video helps you with your homework.